basically ARM processor fundamentals. How a processor, what are the fundamentals of the ARM processor? So how it's going to work, how it is going to communicate with the other peripherals and also other devices. The internal parts of the ARM processor we are mainly concentrating here. So the topics what we are going to discuss in this particular chapter is, first thing is what is ARM processor, how it works. Next one, inside the ARM processors, registers are there. How these registers are going to be useful. And one of the very important register is CPSR, that is current program status register. Just like your status registers which are there in your higher level programming language also. Pipeline, already discussed. Pipelining, exceptions, interrupts and vector tables, core extension. That is not required. We'll go ahead with this. ARM processor core, basically a core. First, we will provide an overview of the processor core and describe how data moves between its different parts. Here, we are not concentrating on the peripheral devices. Our main concentration is only on the core, that is ARM processor only. If the processor is there, how the data is going to be moved in between the different parts of the processor. That is what we are going to discuss. How it is going to be processed. Assume that I am giving some data to the processor, taking that data, processing that, and providing the results. Till there, how it's going to work. That is the discussion we are going to do. We will discuss the programmer's model. How exactly a programmer model will work from the software developer's view. Assume that a software is developing, how the program will execute inside the processor, that we are going to discuss, which will show us you the functions of the processor code and how different parts interact, how the core is going to function and how different parts of the core is going to interact with the core. A programmer can think of ARM core as functional units connected by data buses. There is a figure, I'll show you that figure. A processor, it's a core, it's a functional units. Core as a functional unit, different units will be there. They're all connected with the data buses. In the diagram, in the figure, arrows represents the flow of the data. Arrow mark will be there. That will show you in that direction the data will flow. There will be only one direction arrow mark will be there. There will be two bidirectional arrow mark will be there. There may be. So if it's a one direction arrow mark means the data flow only in that particular direction. Bidirectional arrow means both the directions. It can read the data, it can write the data. Both are possible. The lines represent the buses. What are the lines we are going to have in the diagram? They are representing the buses. The boxes represent either an operation unit or a storage area. As we have discussed in the previous diagram, there are boxes for there where different components we used to come. Here in the ARM core, the boxes what we are going to have, either they will be representing as an operating unit, some operation is going to, or they will be representing as a storage area. The figure shows not only the flow of the data but also the abstract components that make up an ARM core. It is not only the data flow, but also it shows the abstract component of the thing. See, this is the diagram. This is what the diagram of an ARM core and also a data flow diagram. If you can carefully watch this or thoroughly if you see this one, all the arrows are in one direction only. There is no bidirectional arrows here. Just 1 second. Oh, okay, no issues. ఏమైతే అప్పుడు అనిపించే See, when you look into the diagram, this entire diagram is an ARM core, and there is a data flow also is being defined here. There are so many blocks are there here. The rectangular boxes are core boxes. These are all the internal parts of the entire ARM core. Or okay, as we know, processor will be behind the some memory. Memory will be there. I/O device will be there. Everything here. From the memory, see here, from the external memory, I'm talking about the top part. From the external memory, we will be getting the data or we'll be getting the instructions. We may be getting the data or we will be getting the instruction. The data enters the processor code through the data bus. There is a bus. This bus will get you the data. And when it is getting, assume that when the data, it may be an instruction or it may be a data. Instruction may enter into the processor or some data like 10, 20, 30 or A, B, C. These are all the instructions. Assume that one add A plus B, you are going to get add A comma B. So add is an instruction, A comma B, these are all the data. So whatever the value which is present in A has to be added with value present in B, and that may be put into some other location. So whatever we are getting from the memory, it may be an instruction or it may be a data. If it is an instruction, it has to be decoded. It should be decoded. See, generally, I'm a user, I'm writing the code like A plus B. I'm writing a code called A plus B, or I'm writing a code called add A comma B. But machine will not understand add A comma B. It has to be decoded into the machine language. So instructor decoder will take that. Now, see, this architecture what we are having, it is a Van Neumann architecture. Here you might have heard about two different types of architecture. One is the Van Neumann architecture, other is the Harvard architecture. The difference is Van Neumann architecture, both data and instructions, they both will share the same bus. The data items and also the instruction will share the same bus. But in Harvard architecture, there are two different memories will be there, two different buses will be there. One will be used for data exclusively, other will be used for the instructions exclusively. Here in Van Neumann architecture, we will be having only one bus there. Using that bus only, the data also will flow and also instruction also will flow. So this is a Van Neumann architecture. Data is flowing, instruction also flowing. Sign extend. This is one block where it will